All right, so our goal today, this is notes over growth and decay, but today we're just going to focus on exponential growth. Tomorrow we're going to get into exponential decay, and we're going to identify this of when we have word problems, how to write the equation. So, this exponential growth occurs when a quantity is increasing or increases by the same rate over time. So this rate has to be constant. If it is not a constant rate, you're not going to have exponential growth. Now, A is always your initial amount or your original. It just tells you where to start. So if you forgot what initial means, you might want to write the word start above it, just because that's the starting place. Now the rate, the R stands for your rate, and we always write this as a decimal. A lot of times they will give you your rate as a percent, so you'll have to convert. Remember, from percent to decimal, what do we do? So, for example, let's say we had 25% and wanted that as decimal. So let's take 25%, and you've got to take your decimal place wherever it's at, and you got to move it 2 places to the left. 1, 2. So it becomes a decimal 0.25. This works with any percent. You just move it 2 to the left. It gives you decimal, and you need the percent. You go 1, 2 the other way. Now T stands for your time. It could be years, months, seconds. So just know it's whatever the problem gives you, and you'll have to identify that. Now, what we're going to do is we're going to build this equation based on reading the problem, find the initial, the original, find the rate, and then find the time. How much is it going by? So, number 1 says the original value of an investment is $1,400. The value increases by 9% each year. Write an exponential growth function to model this situation. Then find the value of the investment after 25 years. So we want the function, and then we want the investment. So our exponential growth function is always going to be y equals a times 1 plus r to the t. Now, we knew this one was growth because right here it said increases. Tomorrow we'll go into decay where things are going to be decreasing, but increasing is going to be more than 1. It's always going to be getting bigger. Now, let's plug in what we know. Our original value, which is our A, was 1,400. So we've got y equals 1,400. Now, this 1 never changes. It's always going to be in parentheses 1 first. It's a growth, so we're going to do plus, and then we need to get our rate. Our rate was 9%, but we need 9% as a decimal. So we got to take our decimal place and move it 2 places to the left. So decimal not in sight, put it on the right, 2 places, 1, 2. Any empty spaces, put in a 0. So the decimal is going to be 0.09, and then raise to the t. So this is our initial function. Now it says find the value of the investment after 25 years. So it tells us to take 25 and put that in as our time. So let's rewrite this as y equals 1,400 times 1 plus 0.09 and raise it to the 25th. And now we just start solving this order of operations. We still have, we do parentheses first, so 1,400 times 1.09 because 1 plus 0.09 is just 1.09, and it's still raised to the 25th. After we do parentheses, then we do exponents. So we just do 1.09 to the 25th, and then multiply that by 1400. Remember, to get exponents other than 2, use this caret symbol, and then type in your exponent. And we have to multiply that by 1400. So we get 12,072 and we're dealing with money, so let's go 2 decimal places. So 312 means that one's going to stay the same, so 0.31. So he's going to have $12,072.31 if his investment goes for 25 years and the rate is 9%. All right, I'm going to stop the video here. We're going to keep going with the next few examples.